I'm Christina Duffy, and as the imaging scientist at the British Library, most of what I do is multispectral imaging and microscopy of the collection items. And what that does is generate huge amounts of digital data, and then it's up to me to present that in different ways depending on what the researchers or the curators are looking for, or if the conservators have a particular interest in the physical aspects of the collection items, then we would do condition assessments of the items before and after. So a lot of what I do is actually capture, but some of it is processing as well. And today I just want to talk to you about one particular software image processing package, which is called ImageJ. And I'm just going to show you some of the basic things that it can do. And any of the results that I show you today took less than 2 minutes to do. So it's really a matter of just familiarizing yourself with the software itself, but to actually achieve anything that I show you today really doesn't take very long at all. So how can we actually use images? So the three kind of purposes of having an image is to see something, so to read text or to look at an illumination. But sometimes you want to use images to actually discover something, so we're looking at it to try and find new or different information. And then we also want to use it to disseminate that information. So if we have an image, as a result, we want to be able to share that with people. And if you can't do any of those three, see, seek, or sharing with the original image, then you can use image processing to help you to do that. So ImageJ, in this presentation, I'll just show you how it can be used for very basic features like improving the contrast and the brightness, for cropping, rotating different parts of the images, and then also for merging and splitting channels. So I'll talk to you a bit about color spaces, and how most of our images are in red, green, blue color spaces, but if we actually separate those into their separate components, you can see different information that you can't necessarily see from the original. And this is without using any expensive kit. It's just merely manipulating the images that you already have. And then dissemination. I'm going to talk to you about stacks, which is quite important for the work that I do. So a stack is basically a stack of lots of images together, so very useful for something that's changing over time. So you're looking at the same thing and noticing differences. So if you think about a time lapse, you might have a camera looking at a skyscape and things change over time. So for multispectral imaging, you're looking at one thing and different parts of that are changing. And then for making animations to disseminate that information to people. So ImageJ, this is what I'm going to talk to you about today. The first thing you need to do is download ImageJ. It's an open source package, completely free. It's Java based, and the great thing about it is that it has a plug-in architecture. So there's multiple features already on it, but if there is a particular feature that you want to achieve or a different process that you want to do on your image, you can write different macros and plugins for that. It also has a huge user community, so there's thousands of people actively using ImageJ, and there's forums out there, and if you have any questions, people are more than eager to help you or to write programs for your specific task. It was initially designed as a medical imaging tool, so for the National Institutes for Health in the States, in order to look at X-rays and CT scans and anything that had images in it. There's also a user guide which you can look at, but the best way to actually learn this is just to play around with it and see what it is that you get stuck on. So the first thing that's different between ImageJ and other programs that you might be familiar with, like Photoshop, is when you open it up, all you get is this toolbar in the center, and it comes up on the top right on your screen like this. And throughout the slides in this presentation, I'll just try and show you what you would actually see. So what this main toolbar does, it's very simple, but it's an extremely powerful engine, and it's great that it is so simplistic for users, so it's very easy for anyone to use. All of these toolbars along the top, you can click on them, and you get a drop-down menu with many more features. And then in the center, you have these little symbols, which are just different features and tools that you can use. So you have selections on the left, the first one that's highlighted, and make rectangular sections, circular sections, all those basic tools. You can have text on things, move images, different colors, and then the very last one on the right-hand side is just showing you that you can have much more, and there's up to 60 different tools that ImageJ already has for you, with more than 15 different tool sets, and depending on what it is that you usually use for your image processing, you can put them in yourself, so you have your own tools set. So one of the basic things is just changing brightness and contrast, and to do that in ImageJ, once you have your ImageJ open, you just navigate to your file, open the image, and the image will open as a separate window. So once you've clicked on that window, it's activated, and then to change your brightness and contrast, you just go Image, Adjust, Brightness, Contrast. This window then in the top right will open up showing you your histogram, and that's the display range of your pixels. The easiest thing to do is just to click Auto, and that just optimizes it by saturating the white or black pixels and giving you a much clearer image. And that's definitely quite useful for any images that are already out there on the internet that are quite difficult to see, but you just have to remember that you are actually editing the image when you're changing brightness and contrast. You are altering it. So the importance of comparison, this is the idea of stacks, which I mentioned earlier. Something that's very difficult to do is to describe something. So there has been studies done on this. If you give a room of people something and you say, describe it, it might be very difficult for people to actually describe that without having a previous knowledge, or they're biased in what they actually write down as a description. But if you give that same group of people two things and you say, compare these two things, then immediately it's much easier to actually list out what the differences between the two are. So using something like stacks and having multiple images of something and being able to make comparisons between them is a very powerful tool for your own research, really. And one way of comparing things is obviously to open all of your images and just to look at them and see what are the differences between them. To do that in ImageJ, you'd have to go through each one, open them up, and look at them side by side. But that obviously can be quite difficult to see up to 50 images side by side and try and see the differences between them. So ideally we want to overlay them all and just see them change at the same time so that our eyes don't have to scan across something. So if you might be familiar with, there's a reading app called Spritz, which allows you to read text really quickly, so up to 600 words a minute. And it basically works by the words, just the words in the text keep changing to be directly in front of your eye rather than you having to move your eyes and scan through the page. So it's reducing that eye movement. And that's what we want to do here with images that are similar. So to open your images as a stack, we simply go to File, Import Image Sequence. We navigate to our folder of files, and the Sequence Options window comes up here and just allows you to input how many images you have, what scale do you want them to come out as full size. If they're enormous, then you might want to reduce them. And you could also use a virtual stack, which is disk resident, so any changes you make to it won't be saved, but it means you can open it up and it works much faster. And this is an example of what I'm trying to explain about stacks. So when you open up your several images, so this stack I'm going to show you here is a multispectral imaging stack, but I'll show you applications of it in typical images later. So this multispectral image is the same leaf, but there would be maybe 10 different versions of that in infrared, ultraviolet, different parts of the visible spectrum. So different aspects and different colors, different parts of the text might look different in each one. So being able to compare those is quite useful. So when you open up your stack, you have this sliding toolbar on the bottom hand side, and if you click on the play button, you can actually animate the sequence, and you can say how fast or how slow you want it to play. So again, I'll just bring this to your attention. If you tried to compare all of these side by side, that would be quite difficult. But if you stack them together and run it as an animation, then it's much easier to see where the differences are, which aspects are changing. So ImageJ is really good for just allowing you to do research, to see the differences as they are, but also to share that information. So you can use this animation in your PowerPoint presentations, in case your content is lacking. So the digital images that we get at the British Library, you might be familiar with our digitised manuscripts website. And this is where most of our images are held. And as we know, digitisation has lots of advantages. It enables access to a wider community, both nationally and internationally. It encourages education and research, supports our preservation by reducing handling, and increases the profile of your institution. But there are there are risks associated with not presenting the works as they were intended to be in their original format. And what I'd just like to talk a bit about is mistakes that people have made by looking at these digital assets and seeing things that maybe aren't quite there. Image misinterpretation can also be reduced by educating users on the image capture process, and I'd just like to stress that as well. If people knew more about how these images were captured, were more familiar with the type of obstacles that the photographers come up against, and they might be able to see the challenges and to see when they're looking at the images what they might be seeing. And one example of that, a curator was contacted about a particular manuscript that is already digitized, it's online, and they had gone through the entire manuscript and noticed that there were several regions of dots of gold pigment. And they had gone through the whole manuscript and taken the text where the gold pigments was associated with it and made a huge theory about it and sent me this 50-page essay about what it meant and why the pigment was associated with this particular piece of text. But unfortunately, the gold pigment dots that they had seen was actually holes in the folios. So it was actually where pests had just eaten through the parchment. But unfortunately, he had interpreted this as being pigment and got completely carried away with what it might actually mean. So knowing about the process of image capture in that case, because there's obviously holes in that particular manuscript, the parchment was quite translucent, so the photographer had kind of held the folios slightly separated, so if there was a physical hole in it, the camera wouldn't be able to focus on the folio underneath, so it would come out blurred relative to the actual folio. So it would look quite smooth and could be interpreted as being a dot of gold pigment. But unfortunately it wasn't. Another example of that and how ImageJ could kind of prove the case was in this particular manuscript, which you might be familiar with. This is from Beowulf, and this is the opening page to the epic poem, and the area he was interested in, he looked online, and down in the bottom right here where it's kind of stained, he was interested in this region here where the actual name Beowulf, he was looking at this letter O as an A and saying, why is this vertical hard stroke on the right hand side? Maybe it's meant to be an O as an A. And he wanted to actually come in and to look at it himself. Obviously this is a very important manuscript, so you need to have a very good case to get permission to see it. So our curator asked if there's anything I could do with the images to kind of prove that it wasn't what he was saying it was. So we can use ImageJ in this case. So what we have to do is, basically what it looks like is it's ink from behind. So how do we show that without just saying scroll to the next page and you can see it's very difficult to see in that side-by-side comparison. So we try and use this idea of stacks again. So in this case, we take the recto and the verso and we crop it roughly where the two areas are. They don't need to be exact. But obviously the image that we take from the recto side we're going to have to mirror because it's the back of it, so we can't overlay a direct crop. ImageJ lets us do that simply by clicking transform, flip horizontally, and then you get the mirror version of that side. So once we have two images, we can make a stack. They don't need to be multispectral images, you just need more than one. So we now have two images, we have the front and the back of this region, and because we're probably not going to have cropped in the exact position on the recto side, we can register the two together in order to align them. And we do that simply by clicking stack reg, so register to align. And there's several different options for types of alignment. So you have rigid body, translation, and depending on if your manuscript is warped, you might need to do a translation or scale rotation. If it's a small contained region like this, we can just use rigid body. So that's what we did here. And then once we have our stack, we can play it as an animation, and then it's quite clear that the stroke that he's seeing here is actually this from the recto side, and you can see this as well as coming through. So once we send this back to the researcher, it's quite conclusive and he's quite happy with our result, rather than just saying click to the next page, you'll see that it's synced from behind. It can be quite difficult. So that's a useful application of stacks. We have lots of applications of that where ImageJ is used. So this is from Sir Gawain and the Green Knight, and here we're just stacking together infrared and the original together, and we can see underdrawings. Similarly, for some of our Asian and African collections, we can stack together these seals and inscriptions, which are difficult to see with the original. We have very complicated illuminations in the Mura Ramayana, which we can see differences in by stacking. And we can zoom in on different parts of that and see where the artist has changed his mind about different areas. These are all really small files as well, so you can upload them on blogs, Twitter, Facebook, wherever you like. And for our conservators, these are quite useful for actually seeing the quality of the ink. This is from the book of Sir Thomas More in a particular area that there was crystalline blooming formed on. A small note about maintaining the integrity. If you are doing rotations and transformations, again, you have to remember the geometry of the pixels. If you're rotating something that's square 90 degrees or 180 or 360, then it won't be changed. So if you look underneath this and we zoom in on the pixels, we can see that if you translate so that's not 90 or perpendicular, you can get some blurring. So just be careful what you're doing. The idea of color spaces then. This is useful for revealing hidden information by just looking at something in a different space. So a color space basically just means the range of colors that a camera can see, or a printer can print, or your monitor can display. Most of our images are in red, green, blue space. But other color spaces that you might be familiar with might be the CMYK, so the cyan, magenta, yellow and red. And whereas in the red, green, blue, it's an additive process, so you're adding together a red channel, a blue channel, and a green channel. In the CMYK, it's a subtractive process, so you're trying to get rid of areas of white using those 4 colors. And this is just shown on the left-hand side here. This is a printout of a folio from a manuscript. And when you use a microscope to zoom in on that, what appears to be tones of brown and parchment color, in the original, when you zoom into 200 times, you can see it's actually just 4 colors overlaid in different amounts. So how can we use that? This image here I've used is a Ming Dynasty banknote from our British Library collection. The image on the left is the original image that we have, and we can split that into its 3 components in ImageJ by just going to color split channels, so literally click, click. So these are the 3 different channels. In this case, there's not a whole lot of difference between them, but maybe if we put it into a different color space and split those channels, there might be a difference, which there is. So to convert this particular image into a different color space, we simply use a plugin. There's 2 plugins, Color Space Converter, Color Transform, and we just select which one we want to convert into, click, and then do your split channels again. And in this particular case, there's a huge difference between the 3 channels. So when these 3 are added together, they still create the LCH LUV color space. So this has been immensely useful for our researchers who are particularly interested in the seal that's on the front. Another example of this is from the Book of Mullings. So Bernard Meehan in TCD in Dublin. He was looking at this image on the top right hand side, and he could kind of make out some kind of image but couldn't quite make it out or say what it was. So he sent me an image and said, is there anything you can do to, I don't know, make it appear basically. So basically this is a RGB image, put it into a different color space, and like we saw before, suddenly we can see huge amounts of information. And this is simply just using the image that we have. It's not using any expensive multispectral imaging kit. So this has allowed Bernard to redate the manuscripts, and we've used it on many more of the folios since then. So very simple technique to use. If that all seems really too complicated, which it really isn't, there is actually a website called RetroRevealorg, and it does all the work for you, the 2 clicks that you have to do. You just upload your image, and it will give you all of the possible channels. So this might be useful if you don't know which color space to convert into, so you don't know which one might be useful. In this case, it just spews out every single possible result, and you just go through and see what is useful. For instance, this page from the Book of Kells, just upload the color image, and it will give you 52 different varieties of that. So depending on which aspect of that you might be interested in, something might be clearer, which would be useful to you. So some of the ImageJ features, it runs everywhere, Mac, Linux, any of the platforms. It's open source, completely free. There's a huge user community, which will help you if you have any questions about it. It has a massive toolkit. I've just briefly picked out 2 of thousands of them. And it opens up all different file formats, which is useful as well, and allows you to interchange between them. And you can look up more of the features yourself. So physical objects and their digital images, there are of course risks associating, as I've mentioned, with presenting works in the format which is not the original. And image misinterpretation can really have serious consequences for your own personal research, for your institution's reputation, so you do need to be careful about what you're claiming you can see if it's not actually there. And if you can try and get an understanding of the image capture of the institute, whose images you're looking at, that would really be useful for understanding. And of course it's not meant as a permanent substitute for the real world. So the conclusions, to wrap up, the point in looking at things is really to grow our understanding, but it's also a transformative act. We have to remember that the human desire for conclusions is greater than the desire to observe. So with a scientific background, for me it's very easy just to objectively look at something. But for somebody who really wants a result, something to mean something, you kind of have to keep yourself in check, which can be quite difficult, excuse me. These conclusions were so powerful, I came to them twice. And here are just some key resources for you, but really if you just do a Google of ImageJ, download it, have a play around, there might be some useful things that you can do to help you. Thank you.
Thank you very much, Christina. Are there any questions or comments?
I just wanted to add that ImageJ has been used for at least one paleography project or piece of software.
Oh, has it?
A few years ago by Maria Gurrado, who worked with the IT friend to develop what is called graphoscope.
Oh, okay.
Which is mainly meant to help you take measurements of digital images of manuscripts and things, and then elaborate the data, feed them into spreadsheets as well.
Yeah, it's really good for that. So another project that I'm starting to do at the library is for dust collection. So we're trying to see where is the dust collecting most in the library, so we can do more cleaning in those areas, protect our collections. A worthy cause, I think. But we can do that by putting some glass slides around the doors where people maybe are most active. Then if we take a picture of that slide over, say, a week, we can do kind of a time lapse on your glass slide and see how much dust is growing on that slide, do a little animation. But then we can do particle analysis on it, so see how fast it's growing in which particular area, and then we can plot out where it is that we need to send our cleaners to stat. So there's multiple uses for ImageJ. Yeah.
I have a question. So you were saying that you don't need to take images like do a multispectral imaging, where you can it replace that method in terms of what you can learn from?
It can't replace it, so using UV and infrared you'll never be able to replicate that. But there are lots of times, as you can see, using colour space, where if you can kind of see something, then there's a very good chance colour space will help you. If you can't see anything at all, then multispectral is going to be what you require.
So it can also be a step, so you can use that, and then if you see something, you can then
exactly.
Go, okay,
Yes, it is a very good step. So if people come and want to have time on kit that's used quite a lot, quite expensive to get funding for, if you send them and say, well, do a quick, see what you can see, and maybe there'll be a case for actually doing a project.
Well, thanks very much.
Thank you.